In this example, we use two helpful tools that will allow us to avoid some confusion when solving 8.7 subtract x divided by 4 equals -3. To solve the equation, we need to isolate x on one side, so we will reverse the order of operations and undo the operations on x from the bottom up. Reversing the order of operations means that we undo addition and subtraction first, but the subtraction between 8.7 and x divided by 4 may tempt us to add 8.7 to both sides, and this would yield the wrong solution for x. To avoid this mistake, we'll use our first helpful tool, changing subtraction to add the opposite, a tool we used in a previous example. As you may recall, whenever subtraction seems confusing, we should change the subtraction to add the opposite. What do we mean by change subtraction to add the opposite? Well, for example, 12 subtract 5 is the same as 12 add -5. You should push pause and use your calculator to verify this. It's important to note that we only change subtraction to add the opposite. Changing a negative sign to add the opposite is not appropriate. Okay, to practice safe math, we'll change 8.7 subtract x divided by 4 to 8.7 add -x divided by 4. While the parentheses are not necessary, we should use them to clearly separate the addition from the negative sign. Now we're ready to undo the operations on the same side of the equation as x. Since x is on the left side of the equation, we look at the left side to determine our next step. Since we need to undo addition first, we subtract 8.7. And to keep the equation balanced, we also subtract 8.7 from the right side. Working from left to right, since 8.7 subtract 8.7 is just 0, we simply cross them out. Then we bring down -x divided by 4 and discard the parentheses since we no longer need to separate the addition from the negative sign. Next we bring down the equal sign and then we perform the subtraction on the right side of the equation to get -3 subtract 8.7 equals -11.7. So now we have a new equation to solve. -x divided by 4 equals -11.7. We still need to isolate x on the left side of the equation, so we need to undo the negative sign, and we need to undo the division. But which should we undo first? Well, a negative sign is the same as multiplication by -1. For example, -1 times 7 is -7. So we actually need to undo multiplication by -1, and we need to undo division. But multiplication and division have the same level of priority in the order of operations, so it's our choice which operation to undo first. Let's take care of the negative sign first. To do this, we'll use our second helpful tool. Since -1 times -1 is just 1, and since a negative sign is really just multiplication by -1, we know that multiplying the left side by -1 will cancel the negative sign, i.e. undo the negative sign. So we multiply the left side by -1, and to keep the equation balanced, we multiply the right side by -1 as well. Working from left to right, we have -1 times -x divided by 4 is just x divided by 4, so we bring down x divided by 4. Next, we bring down the equal sign and perform the multiplication on the right side to get -11.7 times -1 is positive 11.7. And we have another new equation to solve. X divided by 4 equals 11.7. We can clear the fraction on the left side of the equation by undoing the division. To undo divide by 4, we need to multiply by 4. And to keep the equation balanced, we also multiply the right side by 4. Again, working from left to right, we can cancel the 4's because 4 divided by 4 is 1, and 1 times x is just x. So we bring down the x. Next, we bring down the equal sign and then perform the multiplication on the right side of the equation to get 11.7 times 4 equals 46.8. So the solution is x equals 46.8. You should confirm that the solution is correct by substituting x equals 46.8 back into the equation, and then use the order of operations in top-down order to calculate 8.7 subtract 46.8 divided by 4 to determine whether the equal sign holds true.